I like the chicken better. We'll say that. But I don't care either way.
I like the other one. How much do you have to? I haven't gotten either in a long time.
More than you. It's like $4.25, $4.50. Yeah. What? I know, thanks. Yeah, I know. Because some teenage boy eats way less than me. So let's charge $3. That's stupid. Anyway. Sorry. I'm done.
You're welcome.
Okay.
I don't know what day.
Okay, so we are talking, what's the FTC? What's the FTC stand for? Fundamental Theorem of Calculus. There is a second part, which I believe I alluded to when we talked about the first part. So I want to, you do not even have to put this in your notes. You can, but let me say this. You never have to do the thing I'm going to ask you to do, okay? I just want to show you something that happens. So let's say we had the integral. I'll even make your life. Let's see. Let's say the integral from 4 to 2x of, we got to make this t. Let's make him 3t squared dt. Okay, so first of all, that's weird because what the heck, I have two variables in there. We get to two variables later. This is not hard. It's actually not hard. What I want us to do is let's use the fundamental theorem to calculate this. Okay, so if we're going to use the fundamental theorem, we have to do the antiderivative. What's the antiderivative of this? T cubed. And we're going to plug in 2x and we're going to plug in a 4. Okay, so if we plug in the 2x to that, what do we get? This is not rocket science question.
2x cubed.
Yep, 2x all cubed, right? And then we're going to subtract 4 to the third, right? Okay, now, this is the answer. I want you to do the derivative of that. Of your answer. Of the entire thing. So we're doing the derivative of this guy right here. Okay. What do you get?
3 times 2x squared minus 12 times 4x squared.
Nope. No. What is, well, listen, this just threw you off the way it's written. What is that? 64. It's 64. What's its derivative? Okay, let's go back to the first thing Caleb said. So Caleb said 3 times 2x squared, mostly correct. Times 2 because chain rule, right? So times 2. So this is 6 times 2x squared. Now, what?
Oh no, I did it and then I did it wrong.
Okay. Or another way that I could have written is 3 times 2x squared times the 2, right? Which I just want to show you because of what I'm going to show you. Look at the original. It's 3x squared, 3t squared. Okay. So the derivative of an integral, if we do an integral and then we do a derivative, you get back something that looks similar to what you started with. Because derivatives and integrals are processes that cancel each other out. Okay, so the second part, I said that. The second part of the fundamental theorem says if you have the integral from c to x of f of t dt, I don't even want to put the if there. We're going to do the derivative of that.
You said dt, or is it?
Yep.
Did you make it?
Nope.
You wrote it?
Nope. Oh.
Oh, that was
Yep. It was a good catch.
So if I forget my dx, I get the whole thing wrong, right? I keep forgetting it on all my work, and I'm really worried.
You're,
Will this work in the calculator, like what we're doing right now?
No.
Like, it won't work.
okay. So if we're going to do the derivative of an integral, then the answer is f of x. Okay, now there's some variable switching going on here. So I want to make sure that you know that. So two things. Notice these two guys are different letters. This is a function. This is weird. We're putting an x up here on the top of the integral. And this is a constant.
Wait, is that supposed to be D2?
It's a t. It's a t. It was an x and I screwed up. And this up here is going to be a function. Okay, so this is a shortcut. Basically what we're learning. So the second part of the fundamental theorem is a shortcut, but it is a limited shortcut. Okay, so it's limited only for if there is a constant on the bottom. But having said that, I want you to listen to me. It's super important. Hence, it's fundamental, right? It's really important. It's all over the AP test. Okay, all over the AP test.
With the think back to the rules where like if it's greater, it has to be on top. Is there anything
Just
like values of x where you have to flip it?
the constant has to always be on the bottom here.
You can take a negative out or add one.
Correct. The constant has to be on the bottom.
I'm saying if like we have a value for like different x values, like an x.
You won't.
Okay.
It has to be a constant. David.
So I just got here, so I'm just saying if I'm understanding this right. The derivative of an integral from a constant to a function is
Just observe. Just observe. This will help. So let's say we have, okay? So let's say we have this, and I ask you for the derivative of this. Dang it. I think it's got to be x. Okay? So this says that if you have this situation where it is a constant on the bottom and an x on the top, all you have to do to take the derivative of an integral is replace this variable with this thing here. So it literally is the square root of x. Okay, it's pretty easy. So let's say you have, let's say I'm going to say this is y equals, let's make this -1. Let's make this x, and then let's make this t squared plus 6t minus 1. Okay, I want you to find, so this is another way I could write it. I want you to find y prime. Okay, it's the derivative, because I asked for y prime, the derivative of an integral. So your answer would be x squared plus 6x plus 1. Or minus 1. Because I had coffee again this morning and I feel like it made me stupid. Go ahead.
Was the first example we did, that one was equivalent?
Hold on to that thought.
Okay.
Wait, what happens to the -1 or the 4? What happens to the constant?
What happened to the constant when we did this up at the beginning?
Because the first one's why does y?
Why? Because you're doing an integral, but then you're doing a derivative. What's a derivative of any constant?
Oh.
Garrett figured it out for me, Ms. Douglas. He was thinking ahead.
Very good. Okay, so then let's say y equals 2 to 2x, and let's make that square root of t dt. Okay, I'm looking for y prime again. This one's going to relate more to our first example that we did. Okay, so I'm going to guarantee that most of you are going to say to me that the answer is 2x. But it's 2 square root of 2x. Okay, why? Chain rule. So this is a derivative. We have replaced this. This is our inside function now. When we do the derivative of anything with an inside function, it needs the chain rule. So there's a sneaky little bit in there with the chain rule, but otherwise it's the same, right? This is the derivative of the inside. Okay, that's why this guy up here, I shouldn't have picked him. I should have just stuck a regular x. That's why this guy is 2 times 3 to the 2x. That's why he's 6. So the 3 to the 2x is there, right? The 2x went in for the t times the 2 from the inside. Okay, so I want you to so just multiple ways you can see this. So I want you to differentiate the integral from -5 to sine x of t squared. Okay. So sine squared, right? Sine squared x times cosine. Yeah, right? It's sine of x squared times the derivative of what you put on the inside. Right? Derivative of inside sine is cosine. So don't forget the chain rule.
Chain rule always comes back.
It always comes back. Like this calculus is one of those classes where all of the things still play into it.
So it's a bad idea to take a break between calculus.
It's a very bad idea to take a break between calculus classes.
Okay, so you can't do like power rule. Like, is there only chain rule from this type of like what about like t squared
Okay.
up earlier that we did?
Okay, just a second. I don't know if this is what you're asking me. Just a second. Just a second. So let's go 6x squared. And let's make this natural log of t. Okay? Listen, plug in the thing and then do chain rule. Like literally, it is that easy.
Okay. I think I need to think about it like plugging in writing another equation.
Yes.
If I just try and look at it.
No. Okay, so listen, 2 steps to this. All the time, 2 steps. Plug the top in for whatever t is, right? Plug the top thing in. It creates an inside function. So this is going to be natural log of 6x squared times 12x, which does not go on the inside. You can't change the argument of this. It's 12x times natural log of 6x squared.
Oh. I have 2 over x.
You did the derivative of natural log, right? So the function that the main function that you're working with will never change.
Okay.
Okay, so that was my question earlier.
Oh.
I was asking
Okay, that was
t squared plus 6t minus 1. I was wondering why that didn't change.
it never changes.
Okay.
So you only are chain ruling when the thing that you're plugging in is, I mean, we're doing it up here, but the derivative of x is 1, right? And so you're just multiplying, plug this guy in times the derivative of what you plugged in.
So if it applies
You do it.
So can we like not even worry about looking at where the chain rule is? We can just say like do the derivative of the function on top and then times it by whatever constant
Yeah.
is on the side. Okay.
So if it's
It is chain
inside
rule.
something.
Yeah, so it's only chain rule, I guess. Like Gary asked if it was only chain, it's only chain rule that you're doing because you're creating an inside function. But you're never doing anything with this guy. So I could give you the most ugliest thing. I'm not going to make it terrible, but like, let's say give you something like this. This is fabulous. 2x, what if it was sine t, natural log t, e to the t dt. And I like, what the heck, right? This is the easiest problem in the entire world. Yeah, and you're done. And you guys, it's impossible. This is an impossible derivative. It's probably not, but we don't even want to attempt it. Okay? It's an impossible antiderivative is what I meant to say. Okay, so this is, you got a shortcut for this. It's not a shortcut, it's just the way you do it. So this is sine x, natural log x, e to the x. Done.
So, for example, if it was like 2x, it would be 2 sine x.
Okay,
No,
so
2 sine of 2 of x. And then
so-
same thing for
so it would be 2 sine 2x, natural log 2x, e to the 2x, but only 1, 2. Because there's only,
because they're all connected.
they're all connected.
Do you have to explain on the AP test that you use that shortcut?
No way.
No.
They just expect you to do it. There's no other way to do it.
We don't hear about the methodology so long as it's correct.
Isn't there a cosine?
Why is there no product rule there?
Why do we have to do a cosine with the earlier one then?
Because, where is he?
Because it's squared.
Because that's what I put on the inside.
Oh.
This is not inside.
Oh yeah. Okay.
Okay, this is not the inside, so no
Yeah,
signs.
It's not t squared this time.
Correct.
Yeah, I remember.
David. Because we are not, look at what this says. This is this. No differentiation there. It is what it is. Don't change
Why
it.
do we have a square on-
Here,
Why do we do chain rule? Then why do we do chain rule?
what's the derivative of the inside function?
Why are we?
Because you're doing a derivative. Doing a derivative. Anytime you do the derivative, you do the chain rule. Period. So if you are plugging a function onto the inside, you do the chain rule. What is the derivative of 2x here?
Oh, you do the derivative of the function, not of the sign.
Yeah. See, it's derivative. Are you just asking me about terminology, Caleb?
Yeah.
Yep, just means do the derivative.
Which terminology is most likely to differentiate?
This actually is a free response-y type thing. Okay, so now, with that as background, we need to talk about something called accumulated area. Okay, so we're going to talk about the accumulated area function.
How much space is this gonna?
A lot.
You need some, David?
No, I got the name.
Okay. I guess I misunderstood out of paper.
No, I'm out of paper in my calc section, not in my government
Oh,
section.
you just got yeah, you don't really need paper for government. It just gives out the packets.
Yep.
Didn't want to do that. Crap. Ignore that guy. No, the line that goes down.
You're never allowed to drink coffee.
You guys, I couldn't even spell the word label earlier today.
That's bad.
I know.
How does like L-A-B-L-E?
I spelled it L-A-B-L-E, and I was like, this is stupid.
You didn't lace your coffee this morning or something?
Feels like it.
So where did you get this coffee
That's probably the problem.
Who gave it to you?
I got it from, what is that out there? Gary's Mini Mart. Enough said.
The Gary stuff.
I'm trying to remember. I remember Raj's.
Raj.
What's his dad's name?
I don't know.
He's the one who owns it.
Yeah.
Gary. It is Gary, actually.
Yeah, they do that on the place that they gave.
Okay, I mean, that makes logical sense.
Whoops, -2.
I sure hope so, Joe. It used to
Is
be
that
there for
line meant to
Ashcroft.
be there, the last one in six?
Yes,
Ashcroft.
it did used to be Ashcroft, you're right.
I didn't know that.
What on earth is going on?
Just leave me alone. -2 to x of,
Did you have to pick one that looks like torture?
this is f. Okay,
These torture draw.
You know, Ms. Douglas, you could just have us like write down from your notes for you if you want.
thanks.
What's happening?
Okay. Ignore the scribble. This is what you guys, so yesterday, this is kind of funny. I have a young man in one of my classes who is visually impaired. So he writes always with erasable pen. So yesterday I was writing in pen on my notes and I kept making freaking mistakes again because I had coffee. And he comes up afterwards. He goes, I think you need my pen.
That's fun.
I was pretty big at that. He's like, you should try it out. He's like, just go ahead and write something and then erase it. I was like, thanks, dude.
They're pretty sweet.
It made me laugh. I was like, I appreciate that. I appreciate that.
I feel like I used to have those too. It didn't always work the best.
No, it doesn't always erase. This one worked pretty well. It erased pretty well.
Isn't it kind of like a rubber?
Yeah. And so then he looks at me
Well, that's what
today.
eraser is.
He looks, it's harder though.
Yeah.
He looks at me today, he goes, I did forget to tell you this. He said, if you leave your notes in a hot car, because this works with heat, he said, it will erase everything. I was like, okay, then maybe I'll just scribble the things out.
Because it's
Because it's
friction,
heat, it's the
yes.
friction and the heat. So it made me laugh anyway. Okay, so
Good thing it's winter.
He sounds like he's speaking from experience.
it does. I felt like that was hard-won experience on his part.
Dude, this ink, Ms. Douglas,
The ink goes away.
My erasable pen for this homework.
I left it next to the stove.
Dude, I accidentally sat on my homework and it's all protocol.
Okay, so take a look at this guy. This is a function now. Okay, so we've just been dabbling in the second part of the fundamental theorem. Okay, it's related to this, and this is why we have to know about the second part of the fundamental theorem. Okay, so this equation is f. So this is called an accumulated area function. So let me have you find a couple things for me. I'd like you to find g of -2, and then I'd like you to find g of 2.5.
All with the X on the top.
Okay, now here's what I want you to see. This works as function notation. Okay, so g of x, if I'm giving you this, I'm giving you my x, or I'm giving you what x is. So as soon as you do g of 2, you're looking, sorry, g of -2, you're doing the integral from -2 to 2 of f of t dt.
It's from -2 to -2.
Yep, I said it wrong again. -2 to -2, which is, and you're done. So that works like function notation.
That's just for negative.
But you start at -2. Okay, so if I wanted g of 2.5, then I'm doing the integral from -2 to +2.5 of the f function. Okay, which is your graph, is the f function. So
Why do you start yours from the bottom?
calculate.
Oh, so you do it from -4.5? Oh, I thought it was just like this. Ms. Douglas, so it doesn't become f of -2?
No, it is this. It goes here. Because it's function notation. This is t. This is x.
I know, I thought
So
we
you
were
can't,
gonna
yes,
replace things.
nope, you can't. Because I'm not asking you for the derivative.
So this is where you just have to take these and like these two numbers,
You're talking.
pull them out, and then subtract. You do the what?
So you just find the area of the triangle. It's like when we count all the areas of the shape.
Because it's a definite integral. Alex, question?
Why is it from -2 to 2.5? Is it just to cover the base of that triangle? Because from -2 and then g of 2.5.
Because that's what I asked you for. I could have asked you from -2 to 2. Same difference, right?
What would happen if you asked for a number that was lower than the constant?
You know what to do.
Okay, that was my question earlier.
Yep.
I'm just making sure we're used to it.
Okay, so
I don't remember.
you guys, this is definite integral. Back to the definition of definite integral. Definite integral is area under the curve. So this is the area from -2 to 2.5. It's a triangle. What's the area? 4.5. Yep, it's 4.5.
The height is equal to 2 and the base is equal to 4.5 and the height is.
Yeah, thank you. It's 4.5. Okay, so I could ask you, like, let's do G of 2.
I know, that's what I'm saying. I get one master.
I know, I could read it.
Dang it. I don't even know what I'm just gonna, lighter in New York City.
Okay. What's G of 2? 4. Okay. G of 4. Take you a minute on that one. And then I also want you to find G of 6. Okay, G of 4 and then G of 6.
Is there, for the G of 4, is that G of 4 from -2 to -2? Or is there something under the -2 that's very small?
It's a 4. It's under there.
Basically the same thing, but just like, but it's like
I'm just
said,
making sure, because it didn't look like it.
The -2 is from the other one.
I just wanted to make sure.
It wouldn't matter because the 4 is being plugged in there.
Ooh, that's nice.
From -2 to -2.
Is there a way to do this without a graph, Douglas?
No.
Because from 2, from -2.
I couldn't imagine what
Yes,
you
I understand that, but I'm saying, if it was -2 to -2, it's like 0, regardless.
Holy smokes, you're done already?
How do I even know this stuff? There's so much writing.
2, 3, 4.
Which is the best area.
So this is negative.
And the area of that second little triangle, that third triangle, there's
1, -2, 1. And then what was this whole mess equal to? 4.5.
Yeah, the big triangle's 4.5. The other two triangles are -1.5 and 2.
Yeah, this is -1.5. But yeah, I got 3. That's the one. That's the only one I need. I'm only doing one of them to save my hand.
Okay, so what's G of? Let me ask you, what do you need to do? I don't feel like that's your spot, Avery. I feel like Aiden sits next to Miles because I never in my right mind would put Avery next to Miles. Make sure you take care of that tomorrow, please. If you're going to find the integral from -2 to 4, what do you need to find? You need the area of the second triangle. Okay? Which is what? What's the area of just the second triangle? What? Okay. It's -1.5. Okay, so if this area is -1.5, this area is 4.5. What's the answer? 3. Okay, if you're going to find G of 6, that's the integral from -2 to 6 of f of t. You just got to do the other one. What's the area of this one? 2. So then what is the area or the integral from -2 to 6? Okay, now here's my question. Do you see why it's called accumulated area? Because you are continuing to just add area to your function, right? Here's the area, this negative, but it's still accumulating, so it's accumulating negative, and then you continue going and it keeps accumulating area. Because you're starting at -2 and your x changes. So your x goes up and you start accumulating area. Alex.
Would you not provide those, G and -2, like all those, and we just like look at the graph and just add them all together? We'll be wrong.
It depends what I'm asking for.
I think she's asking just for G of 6, she doesn't need you to write down G of -2 and 2.5 and 2.
Correct. If I'm not asking for any of them, there is no question. Okay, so on your paper in front of you, Okay, so the one I just gave you, I would like you to do just A, please. Just A. What?
How is it different than what we were doing earlier with the area?
It's just listed more annoyingly.
Like, is this just?
So the ones we were doing before are like just a fixed area where we just say, I want the integral from here to here. Like it will be giving you a top and bottom fix. This could change depending on what the x value is.
Yeah, but the way we were doing them on our worksheet was kind of like this, wasn't it?
Absolutely.
Okay.
So it's the same methods.
Okay, that's what it. Because I mean, I felt like it was.
So since there's an arrow on the back of
It's
this,
just shorter writing.
does that mean that the area is infinity when you draw it there?
If you were gonna just A.
Cause then the area is infinity no matter what. Well then, and then when it's infinity and then negative infinity.
It's actually not
Do we?
infinite. It's actually a finite area. Because here, when you get to this point, isn't this always going to be if you're blocking by ones, isn't this going to be adding one or subtracting one every time?
Yeah, but then that's gonna be adding zero.
So from here out and here out, it doesn't
Yeah,
matter.
but it's just asking for,
Oh,
when it's
But-
asking for zero.
Okay.
well, how do you
So
know it
this
goes back? How do you know it goes back up? Because doesn't it only become?
has an arrow.
Well, no. It keeps going forever that way, right? But if it doesn't go back up, does that still count as part of the area of the graph, or am I just reading?
Yes.
Okay.
Okay.
I don't even know you just asked.
I'm not sure what you're asking. F of 0, find F of 0. What is it?
Zero.
Okay. What's F of 1?
Okay.
Do you want me asking her? Or I'm not sure if that answers your question or not.
These shapes are convenient for accounting.
They are very convenient for counting.
1/2,
I know. It's beautiful.
2.5. Negative.
Mm-hmm.
Okay, Ms. Douglas, this is kind of off topic, but why is it called calculus specifically? I feel like geometry and like
I don't know the
I
answer
mean,
to that
we
question.
do things with like derivatives.
Like, where did the
and
name come from? I have no
we do
idea.
stuff with derivatives and integrals.
We're just making calculations. I think that's what this, there's a bunch of calculuses, so they're all just calculations that are.
Well, and then some of the later calculus, they have different.
Okay.
Like differential equations is like form of calculus, but it's not always called like 4.
Okay. F of 0, please. What is F of 0? 0. What is F of 1? Okay, because you're going, just to make sure that you know what you're doing. I gotta get my pencil because I might have to erase. You're doing big F of 1 is the integral from 0 to 1. There you go. That's that. What's F of 2? Yes, because you're going from 0 to 2, so it's 2.5 boxes. Now, this kind of goes to something Aiden asked me, which half of you might not have heard him ask. What is F of negative 1?
No, it's negative. It's negative one because you flipped them.
Okay, so listen, this is the integral from 0 to negative 1 of F of t. Okay, what do we have to do with this? You have to switch it. And if you're going to switch those bounds of integration, that's what they're called. If you're going to switch the bounds of integration, what do you have to do? You got to make it negative. So it's the opposite of the integral from negative 1 to 0. Okay?
I didn't switch the place that the numbers were when I wrote down the integral, but I have -1.
Whatever. It's negative 1. Do you guys understand why it's negative 1?
Yep.
Because the area from negative 1 to 0 is 1, but you have to make it negative. Now, try B.
I just find my formula for f and x equals
Don't do that one.
well, it's 2.
You're not doing C. You're not doing C.
I'm doing B.
Oh.
You are doing B.
Alright, so I think got it.
It's, not
How can you just create three formulas?
I will tell you if you want to know.
Well, and I don't even actually need it.
Nope.
Okay, I don't want to know.
Okay.
shade in the area represented. It's like f of 3 and f of 1. The data to show that it's mine. How would you
No,
show
but
it?
it's f of 3 minus f of 1. So then you just do. Oh, wait, I think I did a little extra in that.
Okay. So
Because it's 5.5 minus 1.
overthinking. Okay. If I ask you to do f of 3 minus f of 1, what are you shading in? How many boxes? Let's go that. How many boxes are you shading in? 3.5, right? Here's f of 3 minus f of 1.
That's what I did. This one wasn't overthinking.
Good.
anything.
Glad. Okay. F of 3 minus f of 1. Now, I want you to, we're going to come back to D, but I want you to do E and F. Okay, well, we'll come back to D in a second. We are not doing C. Already said that.
Alright, E and F.
Okay, E and F, please.
Am I making crazy bills? Okay.
No, it doesn't want me to explain that. I feel like it's a stupid question.
Can I just say like it has more?
Just is
Can I just say f of 3 fits inside of f of 4?
Oh, there you go. I like that.
That's, yeah,
Couple
so
different
just
ways you could say it.
F of 3 include, or F of 4 includes F of 3. Yep.
Be careful with that because well, I'll tell you in a minute.
Well, yeah, if it's under the area.
Can I just say the area is larger? Like
Like
seriously.
it is bigger. Yeah, like you can find it.
Why
Can I just say?
Because of the
Because it's
area.
bigger. Because it has a.
That's like saying, why is Snow White?
Why?
The numerical value is higher.
Because f of 4 has an
It
area of 6.
accumulated
F of
more
3
area.
doesn't.
Because it accumulated more area, right? You've got, so if you you guys listen, if you compare f of 3, you guys, this is obvious, and so you're having a hard time putting it into words. Here's f of 3, right, on the paper, there's f of 3. Why is f of 4 larger? Because there's more area that you're adding into it. That's it, right? Because you're adding more area, but the reason you're being asked the question is because of the next one.
Yeah. Makes more sense when you read the next one.
Yeah.
Explain because there's
It's above the graph.
Just, can you check my reasoning on this? Like, if it would work.
Same here.
F of 5, F of 6 is smaller because the first inside doesn't have it is negative.
The part that
F of 6 equals 5 doesn't include it. It's like doesn't have.
No, you're wrong because it's asked which one's larger, not which one's smaller.
I know. I said F5.
Yeah, it's hard for me to understand that reason.
Well, because it's saying that.
Yes.
It's like this. This is F5. This is F6. The part that F5 doesn't have is negative. So that's why it's bigger.
There's a way easier ways to say that.
I see
Okay,
because-
what's bigger, f of 5 or f of 6? F of 5, and the reason that, like, you guys are asking me, like, would this make sense, would this make sense? I think what I would say is because once you get past 5, the area that you're accumulating is what? It's negative, so you start to go down. Right? That would be what I would say. Now, with that in mind, the fact that you're going down once you get here, assuming that that continues, that's an arrow there, go back and do D. Remember that we're still talking about big F, right? Big F, which is the integral from 0 to x. So there's 2 places where that integral equals 0.
Only 2?
Only 2. The integral from 0 to x.
I know one of them.
You do know one of them. One of them is easy.
I only know one of them. And we're not able to change the bottom variable. Like
Correct.
It's positive and negative 0, right?
Totally.
Between x equals 0 and x equals 1.
Big
Wait, what is the between x equals 0 and x equals 1? Oh, wait, no, that's the wrong question.
You're totally on the right track.
I just don't know how to do addition.
I may have gone wrong myself.
Or I don't know how to count. We'll figure it out.
I'm
We had
gonna.
coffee this morning and your brain cells are leaking like mine.
I just put it in the give two negatives.
Nope, I counted wrong.
It definitely has something to do with the end of the
It
graph.
absolutely does.
I'm just trying to think of what number I could put down that would work. Would 7 work? I don't know.
Yeah,
I was trying to think of like
Calculate it. See what 7 is? What's up with 7?
not
We just have to
big
do
enough.
trial and error.
Just not 0.
You could,
You can't do infinity.
Use the
either,
brain.
Can you?
What?
I don't
No.
have a brain.
because you need it to balance the positive and negative
Yes, you do.
parts.
Yeah, but we don't have.
Can you splice it?
I'm just trying to understand.
I see what you do. You go off the graph here.
Yes, yes, yes.
And so you calculate what it is up until this point, and then you go to the point on the graph where it equals the top.
Well, yeah, I know we don't have that.
But we know what the graph does because it stays the same.
Oh, because it stays. Oh.
That's hence
Oh, 'cause
why
it
I.
continues to the right, but,
Yeah, because it'll be a rectangle.
but it says continues to the right. That means it could go up or down
Garrett.
to the right.
It continues.
If it continues, that means
If
it
it
doesn't.
continues, that means it doesn't. There's no like changes.
Yeah. Okay, so tell me the easy one. X equals what? The one you already got, right? Now, I heard somebody say this. If you're going to figure this out, this is all going to be negative area. So you have to figure out where does the positive and the negative balance out. So you have to know how much positive you have. How much do you have? 6.5. Okay. You know, if you go to here, what would be the total area? 6. And every time you move to the right one, it goes down 1. So I believe that it's 12.
Yeah.
Because you got to subtract, you got to go down 6 units. So the other one would be 12. Listen, that's not very often possible because it has to be that it does not change, right? Like, but it's good logic.
So because the arrow is there, that automatically means that it won't ever cross the
Correct.
x-axis.
If there's an arrow, it means it behaves the same.
Is there
always.
a way to show that it continues rather than just looking at part of the, like, is there a way to see that, it could go back up to the x-axis?
They will not put that if it goes back up.
Okay.
Like if you
They would
see it,
draw the graph.
they would have to draw the graph.
Okay.
If they're gonna indicate an end behavior, it has to behave that way all the time.
What on earth did Camden chart do to get on the wall of shame?
Jammed my calculator in.